So the Vesper theory proposes that the geometric arrangement of terminal atoms or groups of atoms about a central atom in a covalent compound or a charged ion is determined solely by the repulsions between electron pairs present in the valence shell of a central atom. The number of electron pairs around the central atom can be determined by writing the Lewis structure for the molecule. The geometry of the molecule depends on the number of bonding groups or pairs of electrons and the number of non-bonding electrons on the central atom. The meaning of polar is that there's an uneven distribution of electron density. Water, for example, has a partial negative charge near the oxygen atom due to unshared pairs of electrons, and partial positive charges near the hydrogen atoms. And a nonpolar molecule is a molecule in which the electrons are shared equally between the nuclei, and as a result, the distribution of charge is even and the force of attraction between different molecules is small. Nonpolar molecules show little reactivity. Alright, so the first molecule model we're going to start with is the bent. So your example substance is H2O. Like, what else are you going to pick? Like H2O, alright, like, chill. And then you got the bond angles, like, you got anything less than 120 degrees, like, so yeah. Electron pairs, you can see that you got two shared pairs, one there, then two lone pairs, one there, and one there. And the molecule is polar, and here's the work for it. As you can see, electron negativity subtraction, 1.4 is greater than 0.4, so it's polar. Alright, next you got your trigonal pyramidal. So the example substance is BF3, customary. Bond angles, 120 degrees, customary as well. Electron pairs, there's four shared pairs, 1, 2, 3, and 4, and there's zero lone pairs on the central atom. And the trigonal pyramidal BF3 is polar, and here's the math. As you can see, the electron negativity subtraction, 2.0 is greater than 0.4, and it makes it polar. Alright, so next you got the linear molecule model, like example substance is CO2. What else are you going to use? Linear bond angle, 180 degrees, it's a straight line, like, come on, like, let's go. Shared pairs, you got 4, 1, 2, 3, 4. You got 0 lone pairs on the central atom, and it's symmetrical, so the polarity is nonpolar. Let's go. Alright, next you got your trigonal planar. You got BH3 as your example substance. Bond angles, you got 120 degrees. There's 3 shared pairs, as you can see. 1, 2, and 3. And there's 0 lone pairs in the central atom. And it's symmetrical, so the polarity is nonpolar. Alright, and last but most certainly not least is the tetrahedral. And your example substance is CCl4. Your bond angles are at 109.5 degrees. Shared pairs, you can see you got 1, 2, 3, and 4. And there's 0 lone pairs in the central atom. Also, here are the diagrams for the trigonal, bipyramid, and the octahedral. So there they are. Then you got your subsets, customary. Take a look, have fun. This is the site where I got it, infohost.nmt.edu.com. Yeah, I know I got a good grade on this. Dr. Harvey, gotta be an A. All right, dope.